Okay, then before we start, uh, just want to know that how many people are there. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Before we start, I will give my introduction at the end. Uh, let's have a quick introduction of each and everyone. I just want to know about your background, like from where you are coming from. Like you already have a data science background or a DevOps background, and then you are looking for this MLOps course, or do you have something related information, related knowledge about MLOps? So accordingly, I can explain this demo, or I can add those concepts here if you are not familiar with it. So intention is just to understand your background from where you are coming. So it can be like how many years of experience you have and in which domain you are working. Do you have any software engineering experience or DevOps experience, data science experience, or if it is a IT experience, non-IT experience, whatever it is, just number of years and what kind of experience you have. Okay. So let's start with Sachin then.
Hi,
Hi Sachin.
uh, I'm non-IT background. I am from Mumbai and I have 10 years plus experience.
Okay, okay, good Sachin. In non-IT background, if you can elaborate it, like is it regarding to which field? Uh,
Yeah, means I'm working as an implementation engineer. I don't have this Python and all, means basic knowledge of Python and all.
Basic knowledge of Python. Okay, you work as the implementation engineer. Okay, yeah. Thanks Sachin. So next is Raghavendra.
Hi, Pramod. This is Raghavendra. I'm having 8 years of experience in IT, and I have like a background of storage and Linux administration actually. Yeah. So,
Okay,
but I
okay,
have
very
trained.
good.
I have trained on DevOps. That's
Mhm.
it. So I don't have any background of ML, or I don't have any knowledge on ML.
Okay, but you
Machine
have
learning.
experience of DevOps.
Not experience. I mean, I'm fully trained on DevOps.
Ah, okay, got it,
Yeah.
noted. Yeah. And definitely your Linux experience will be helpful here in MLOps as well.
Thank you. I have Python knowledge as well. Yeah.
Okay, got it. Next is Badal Korape.
Yeah, hi, hi, Pramod. Good morning, all. So I have 10 plus years of experience in IT, but um, in DevOps I have 5 plus experience. So I've been working in medical domain, and I have basic knowledge of Python, but miss here I have miss like joined to know about MLOps, like miss
Mhm.
what prerequisite we should know, and miss how we can work in MLOps. So that's all.
Mhm. Okay, got it. Yeah, thanks, Badal. Definitely your IT experience will helpful here. And since you already have a basic knowledge of Python, don't worry that this course will cover Python as well. So yeah, you do have some links for MLOps. So next is Suresh. Suresh, if you are speaking, we cannot hear you.
Uh, Good morning, Pramod and so my name is Krish Bangaru. I am working in Tekken in financial sector. I have total 6.5 years experience in data science, and I don't know the DevOps. That's it.
Okay, so you have a
Hello.
6 plus 6 years of experience in data science. Does that in
Yes.
data analyst or ML data engineer, to which particular field it is?
Uh, yeah, I am working in ML and
Ah, okay.
computer vision and NLP
Mhm.
also. Yeah.
Oh, this is really good. Yeah. Thanks, Suresh.
Yeah.
Then
Thank you.
next is Chucky N.
Hi, this is Chucky. I have 10 plus years of experience. I'm a DevOps engineer. Day to day activities would be mostly like Linux, Python, taking care of cloud infrastructure, Kubernetes, and everything. I'm just looking for the roadmap for transitioning or acquiring knowledge to move to MLOps or at least acquire knowledge regarding that. That's where I'm stuck. Don't have a clear path yet.
Got it. Got it. Yeah, you do have a really good experience in DevOps. I just wanted to know that have you trained any machine learning model so far, or you know about machine learning as well?
No, in my current company they use Databricks.
Mm-hmm.
So once I get some knowledge, I have to try. But no, like basic ETL pipeline, those kind of things I do have. But strictly
Okay.
with the Michel model, no, I don't have any clue.
Got it, got it. I'm sure that this syllabus doesn't matter if you join this course or not, but the syllabus which I am going to talk about, if you will cover that syllabus, it will boost your confidence since you already have a good DevOps experience. So MLOps is not different from DevOps. So we will discuss it in few minutes. So definitely your experience will be helpful here. Yeah.
Thank you.
So next is Shekhar.
Hey, hi everyone. Good morning. So I have around 14 plus years experience. So mostly I was into a cloud like GCP for almost 5 years. I have a knowledge on the DevOps side, uh, but basically I already worked on Gen AI. So basically I joining this was basically how the LLMs will be deployed to the production. So I'm just stuck on that. So basic knowledge on Kubernetes, Docker image, and everything I already have.
Okay, okay, yeah. So if you will split your 14 years of experience, how it will be like initial 5 years, next 5 years, and last 5 years?
Yeah. So prior to GCP, I was into a Oracle database side. So hardcodely, I was working for almost 10 years into PLSQL and everything. But I moved to cloud GCP. That is where we have mostly done on the data engineering part. So once our work is done, we just push those into the production. So basically, the Terraform, Docker image, and everything I have already worked. So I upgraded my skills into Gen AI part, where I've done some POCs and everything. But how this will be deployed to production? So that's where I need to bridge that gap.
Okay, okay, got it, got it. That there will be a one project deploying a Gen AI applications or LLM applications with MLOps practices. Yeah, I think that will be helpful to you.
Yeah, thank you.
Okay, yeah, sure. Then next is Shiva. Shiva, if you are speaking, I think you are on mute.
Yeah, hello Pramod. Good morning, everyone. So I'm Shiva. So I have 3 plus years of experience working into cloud and DevOps.
Okay, okay, that's really good. Cloud, DevOps both are essential for MLOps as well. Thanks, Shiva. Then Akshay.
Pramod, good morning, everyone. I have around 5 years of experience in data analysis and ML projects. So I do want to bridge that gap about deploying the projects or models on cloud or servers because that's something I really want to get into. And I think I've done some projects in ML, as specifically speaking in finance, not any other domain.
Okay, okay. Yeah, means you do have some links about ML already. You are just looking like how to deploy it or what are the MLOps practices that we are going to follow, right?
Yes, because there are so many tools and it's quite confusing to start with. So that's the reason.
Yeah, you are absolutely right. We are going to talk about that as well. Okay, thanks Akshay. Next is Rajesh.
Yeah, hi. I have total 6 years of experience on Java actually. So basically, I'm not that much proficient in coding, so I'm not able to manage coding. So that's why I choose whether DevOps or MLOps. So that's why I joined.
Okay, okay, yeah, that's good. But just to clear your expectations, Rajesh, that even though DevOps and MLOps are mostly similar, we are not going to do a heavy coding, but minor coding will be required for it.
Yeah, minor code is fine. I can manage myself in Java, but it's not like that, right? We have to manage
Yeah.
the team after going to something, having higher experience, right? So I'm not that much proficient in coding. So that's why I wanted to choose the technologies which has less coding and managing kind of thing. So that's why I chose this.
Yes, yes, yes. You are absolutely correct. Yeah, of course, we don't require heavy coding, and nowadays coding is not a big task. We have these LLM models are there. Those will give you entire coding if you will just give them a correct prompt. So coding is not a
Yeah,
big
and
task.
also I don't have data science and Python knowledge. Without that, I will be able to get knowledge on MLOps, and I'm able to continue. Make if I can I get a job like in MLOps.
Okay, noted, noted. Yeah, we are going to cover those portions as well here. Yeah. Thanks,
Okay.
Rajesh. Next is Ilyas.
Thank you, Pramod. Good morning, team. Uh, I just joined late. I think I just need to update from my end, right? I mean, like what I'm doing.
Yes, Ilyas. Just we are just looking to know the background of each and everyone, like from where you are coming, like from which background you are coming, how many years of experience you have, whether it is IT, non-IT, DevOps, MLOps, already data science, kind of.
Yeah, sure. Sure, Pramod. Thank you. So, like my name is Muhammad Ilyas. Basically, I'm from Hyderabad. So I have around 10 years of experience in IT industry. So it's been 3 years. I'm working as a DevOps engineer. So the main intention of joining this course and this session is, yeah, because DevOps is like a update version of the MLOps. So people are organizations are migrating to MLOps. So I'm looking to to enhance myself, my technology, so that I will be put in the market. So yeah, this is the main intention of joining this course.
Okay, that's good. Yeah, always upskilling is the better way to keep relevant in a market. Yeah,
Right.
thanks, Ilyas. Okay, we have one more person, but I don't know his name. It's coming waiting for name. If anyone is left, they can just continue. Otherwise, I will just continue with this session. No? Okay. Yeah. So my name is Pramod. I do have a total 7+ years of experience in machine learning, data engineering, and MLOps as well. I basically work on MLOps in my last 3 years. Before that, I was heavily working with this data engineering and machine learning engineering. Throughout these last 7 years, I work with the retail industry, financial organizations, then I work with the travel agencies as well. Like there are travel agencies in India, Make My Trip kind of. So these are the giant travel industries. I have worked with them as well. Uh, then my experience is spread across from startup to like multinational companies as well. So I have worked with a startup where they did not know that what is ML and what is data science as well. So from very scratch, I started building everything. So I do have that kind of experience, and I work with MNCs as well, where everything is like with various process. If there are, if you want to deploy any applications, there will be a lot of permissions, lot of legacies that we need to consider. So I have a mixed experience of startup, MNCs, how startup work, how MNC culture work, and from various industries as well. If I will specifically talk about technological stack or domain stack, then I am not expert of computer vision so far, but yes, I have a very good knowledge. I will say not very good, just to put me, but yeah, good knowledge of ML, DL, and AI as well. Okay, and in recent time, I have been exploring these MLOps, and then got to know that okay, this is a booming field, and of course, before 5 years, if you will ask someone, then what is ML? Okay, then people were not aware about ML. They started building these ML applications, and now most of the companies have ML applications, even LLM applications as well, and they want to deploy them. Okay, so we have a huge traffic of ML and the, LLM applications right now in the market, but they don't know how to deploy it. Right now, we are applying those same practices which we are using for DevOps, but DevOps and MLOps both are coming from the same parent, but still they do have a very different flow. They do have a very different aspect to deploy the applications. So that we are going to talk here. So, yeah, do you have any doubt? Then you can ask it. Otherwise, I will just start. Yeah.
Yeah, yeah. So I have a basic doubt. So if, for example, if I learn ML ops, so do I need to learn data science? do I need to have the knowledge on data science as well?
Data science, I will say not complete knowledge of data science, but at least if somebody, of course, MLOps is a part of data science only. So if somebody will talk about some concepts, some words, at least you should be aware about it. So I will say not expert of data science, but very high level language knowledge of data science, so that you will understand language of your colleagues.
Okay, okay. So it includes all NLP, deep learning, and everything, or just
Yes,
we need
of
to
course.
have it high level. That's it.
Yes, yes. See, NLP or ML, DL. I will not use short forms. Machine learning, deep learning, natural language processing, computer vision, or even LLMs. They all have a same chassis. Like all our vehicles have a same chassis, and then on top of it, we build a different kind of vehicles. It is kind of that one. So if you will understand the core architecture, like how these prediction systems work, then it is not a magic to understand remaining architectures. So if you understand ML, definitely understand DL. What is the difference between all of them? That they have some conceptual difference. Along with that, data is different. Like for ML applications, we provide tabular data. For deep learning applications, we provide tabular data or non-structured data as well. But there, we are not, we don't know about feature of that data. In NLP, we have a textual data. In computer vision, we have a video data. So that kind of data is different, but goal or architecture is same. So I think that will be easier to understand once you will get a hands on of the one, at least one architecture. We will have a one quick
Okay.
question from Akshay, and then we'll start. Please.
Okay, Pramod, just one quick question. I do not have any experience on like any knowledge about Docker or Kubernetes. So would you recommend any other course or a video which we can cover the parts which is required
Uh-huh.
for this course?
Trust me, Akshay, I will cover this Docker as well here. But if you will go to anywhere on YouTube or maybe anywhere in paid courses, they will at least take 7 to 8 hours to explain that Docker. But since we all are experienced person, they teach Docker like considering we all are freshers, we don't know anything about this industry or maybe IT. So considering that they will take 7 to 8 hours, I will explain this Docker within 2 or 3 hours, and trust me, you will get most out of it. So you don't need to go anywhere to learn Docker, even for Kubernetes as well.
Okay,
I'm
thank you.
giving you assurance that I will explain you like Docker, most of the useful concept of the Docker. But for Kubernetes, I am not sure if we will be able to explain entire Kubernetes, because Kubernetes itself is a very itself has a very huge syllabus, and it is a very vast field. But whatever things which are required for us, that we will cover, so that at least we can apply them for our MLOps. So for Docker and Kubernetes, don't worry, we will cover it here, and we will cover it in very short time, but still I am sure that you will understand it rather than these YouTube videos. Okay, yeah, thanks, Akshay. Just to extend that point, see, my intention while I explain anything, intention is that why we needed it right now. If there is any technology coming into the market, let's say Docker is coming in market, then why Docker is coming in market? Before Docker, what was the challenges that we all were facing? So once you will understand it, okay, before Docker, industry was like this, and now we need something that will solve this problem which industry has, and who will solve it? Docker will solve it. How it will solve it? Then we will learn Docker. So how it will solve it is a learning, but why and how this, sorry, why is a question that will give you an entire background and thinking as well. So learning technology is not a big task. We can learn it anytime from anywhere. There are a lot of resources as well. But why that technology is coming in, what problem it is solving, if you will understand it, then it will become very easier to understand each and every technology or tool as well. Okay. If there is no question, let me start with this uh, MLOps demo. Okay, so before we start with this MLOps, we will be needing some requirements, or we can call it them as a prerequisite as well. So first one is like basic knowledge of Python programming, But in my last batches, there are people from non-technical backgrounds as well. They are not aware about Python. They not even basic Python as well. So I cover Python in last batches. So I will cover in this batch as well. So if someone is coming from non-programming background, he will at least understand what is Python and basic of Python. We will work with VS Code and Anaconda. VS Code is kind of IDE. If even you is any one of you is from working on Java, then you may be aware about this Eclipse or IntelliJ or Python for PyCharm. So there are various types of IDE. We use VS Code as well. Reason to use VS Code, that VS Code provide terminals and git commits everything in a visualization mode. You don't need to go anywhere out of VS Code to do these things. Anaconda environment. So whenever you want to set up Python on your system, you don't need to go and set up each and everything. Just download Anaconda and it will set up everything for you. Anaconda will even have IDs as well, like PyCharm is there. Then it has a Spider, it has Jupyter Lab, Jupyter Notebook. So everything whatever required for Python, Anaconda will have it inside it. Okay. Next is basic hands-on experience of data science project life cycle. Okay, that is a yes. This is very true requirement for this course. But again, same thing that it doesn't take a lot of time to explain that how data science project life cycle works. Then we will cover it here as well. We will cover it shortly, but you will get it that okay, what is the end-to-end life cycle of the data science project. Even if some of you are not aware about machine learning, which is our third prerequisite. So if there is no knowledge of machine learning, I will build two applications. One is linear regression and one is logistic regression, explaining that what is the mathematics behind linear and logistic regression and how they give a prediction. So we will build those two models to understand what is a machine learning, how it works. Okay, we are not going to cover entire machine learning, but we will cover that okay, what is a machine learning and how we build model, from where we import it. So that basic understanding of machine learning is covered. Okay, and existing account on GitHub, AWS, these are the prerequisite, but no problem, we can create it. So even though I have mentioned these 4 points here that it should be a prerequisite for this course, but if you are not aware about it, don't worry, we are going to cover it here. Okay, reason I mention it here, that at least you will know that what are the things that we are going to use there. Okay, yeah. And that was the case with my previous batches as well. Most of the people were not aware about these things, and it doesn't take a lot of time to explain it. So that's why I included in that course only. Okay. Then what is machine learning? There is a theoretical definition of this machine learning. You can read it and you can understand it. But at very high level, if I will explain to a first class student that what is machine learning operations, then it is like if you want to design or if you want to build something, then what will be your first step? You will gather requirement from the client, like what are the things I need to build. Okay, what is your problem? Okay, if you have a problem, then if you have a 10 problem, I can solve 5 problems out of it. Then please let me know out of 5 problems which problem you want to give a prioritization. What is your highest what is your important problem? Okay, so once you, if someone is coming at you, or maybe let's say client is coming to you and he is asking you that okay, we want to build a machine learning model and all those things, then you will gather some requirement, you will ask him some questions. Maybe that client is coming from a retail background, maybe he's coming from customer support background, maybe he's a financial institute, it can be anything. Then in that case you will ask some question about his domain as well. Okay, to understand his business. And then last will be data acquisition. So it is here, I'm talking about this first section. So data acquisition is here. So you will ask this question to client, or you will collect some information of that client that comes under design. Okay. It means that now you will know what is a problem, what can be a solution, and what are the available things with me. And then next is what should be the prioritization. So doing this analysis is called as a design, and that is available in software engineering as well. Whenever we build any software applications, we do ask this question. So that comes under this machine learning design. Okay, so once we know that, okay, at very high level here we will know what is the problem, what should be the solution, how to approach, how to get to that solution. So that will come under ML design. Next will be, now we will deploy something. Okay, sorry, we will develop something. Now if you want to develop a model, then what should be the requirement? First requirement is data. Then you will ask data from client. Not necessary that data will be a clean data that will be the ready to push to machine learning model. So you may need to do some cleaning or pre-processing on top of that data. So that comes under model development, that once you have a data, you will pre-process that data. So after pre-processing as well, let's say you have 100 columns, but it is not necessary that all of the 100 columns are important. Okay, because it usually happens that if you will ask to domain expert or client, please give me data, they will give you a tons of data. Okay, they will give you thousands of columns. They will not do any analysis on it, on top of it. So that analysis we have to do. Okay, even though we have 100 columns, thousands columns, what are the important column for us? So that will come under this feature engineering. Then next will be simply model training. But nowadays model training is become very complex, because we are not going to train a model on one, we are not going to use one model at a time. We may use multiple model. Along with that, we may use multiple hyperparameter tuning. So that's why experimentation is coming into picture, and that will be handled by ML flow. So ML flow is help us to track this experiment here. And next will be model analysis, that how we build this model and how it is working. So evaluation will come there. So these four stage will come under model development. And then last will be operations. So in operations, what we will do, now we have a model ready with us, we have evaluated that model, that model is working really good. Then of course we should send it to production. So how you will send it to? So you will deploy that model somewhere. Okay, but will you deploy it one time, twice, every week? So it depend on your data. So to do that, we need a CI/CD pipeline for it. Okay, so whenever there will be any changes in data, in model, or any pipeline, you will need a automatic deployment of that model, and that will handle by CI/CD. And last portion will be model monitoring and triggering. So what is a model monitoring? Model monitoring means once you deploy model, how that model is performing. Okay, that will be the one aspect. Second will be, does that model receiving same data which we pass during training? So that will be the second thing. And third will be, is this model degrading? We don't know reason, or there is any concept drift. So there are various factors that can affect our model accuracy. So that is the reason we need a monitoring of our model, so that we can do a retraining. So triggering is retraining, that we will trigger a retraining. Now, if most of us are from IT background, these three phases, ML design, model development, operation, is not different from traditional software engineering. Like what we do in traditional software engineering, we also do a software design, right? We ask some question to client. Here I'm talking about. We ask some question to client, we gather requirement, we do a prioritization. So what is the difference between ML design and software design? I don't think there is a much difference. Only one thing, that most of the time software design does not require data, or does not require a huge amount of data. So during ML design, we add one more point, that is a data acquisition. So that is not a part of traditional software engineering, but during ML design, we need to consider what is data, how it should look, from where it is coming. All those things will come under this ML design. So I'm talking about difference between software engineering and machine learning right now. Okay. So for ML design, there is a one difference, that data acquisition is not part of software design, but it will be a essential part of ML design. You will ask some question about that data, from where it is coming, how it is coming, what is the quantity, what is the quality aspect. Then for deep development, again in traditional software engineering as well, we do a development, right? We all are a developer. So what we do, we may build a develop a Java application, we may build a front end, back end, all those things we do. Then how it is different from this machine learning development? Okay, so here in machine learning development, like we gather a data, we need a data. Like in traditional software engineering, we are not concerned about mathematics, but here we are concerned about mathematics, that okay, what should be the mathematical steps or what should be the mathematical approach for this data so that we can use this model. Training is not there in software engineering. So let's say if you are building any application, you don't need a training. That application will be a simply a function that will take some information, that will give you some information out of it, right? So training will not be there in traditional software engineering. But yeah, of course we do a testing, quality testing, that how this application is working. So same here, we do a testing, but we do a testing of our accuracy, okay, that how accurate this model is. So that is very high level difference between software development and model development. Okay, here we have a data, here we concern about training, and here we concern about model accuracy as well. Next and very important phase, which is development operation and machine learning operation. So what is the difference between development operation and machine learning operation? So in development operation, like we call it as a DevOps, here we will have a one software applications, we will deploy it, and you will only redeploy it if you will do some bug fixes or if you will do some improvement in that application. Then and then only you will redeploy that application. So as compared to MLOps, DevOps becomes very simple. Okay, even though it is complex, but conceptually it becomes very simple, that whenever why DevOps is there, if you want to redeploy something by doing some improvement in application or maybe by fixing some bug in application, then and then you will do a CI/CD pipeline, all those DevOps things. But for MLOps, it becomes very complex. Why? In ML, your application is not only depend on, you will not only redeploy your application if there are any bug fixes or there are any improvement. You will redeploy your application over a period of time as well, because right now let's say I have built one application, and that application is let's say for uh, online shopping industry. Okay, so I have built some taken some data from online shopping industry and built some applications over there. But you will notice that these online trends are continuously changing, and these are seasonal as well. Like during festival season, you will have a different trend. During winter, during summer, you will have a different trend. Even though it depend on economic situation of country and world, even though it's depend on years as well. Like what was the trend before 2 years, what should be the trend after 2 years right now. So these are the moving parts which comes with this model. So model is not a constant, means the things around model are not constant. Data can be a moving, data can be a changing. Second is concept. That concept we are using to build this model, that concept can be a changing. Okay, so there are a lot of moving parts, and that's the reason ML model are needs multiple redeployments, or they need continuous improvements. Okay, as compared to the software applications. Reason, because we have a multiple moving parts with this ML. We may have a moving parts related to data. We may have moving parts related to train. It can be a concept. All those things are there. Let me explain some things here. Mostly we do retraining based on two things. One is a data drift and second is a concept drift. So we continuously monitor these two things, that if there is a data drift or not. So what is a data drift? So you can consider it like this. If you want to build any application for bank to predict if particular customer is fraud or not, then you will take some information of that customer. What can be that information? It can be like how many, what is the age of customer, what is the income of customer, okay, what is the credit score of customer, and maybe you will consider that what is his track record for past loans. Okay, then you will say, okay, this customer can be good, this can be a bad customer. Okay, but now let's say if your data of 2015 or not even 2015, 2020 customer behavior before at on 2020 or 1819 is very different from today's behavior in 2024, 2025, right? So if you will use same data, if you use that data and if you train that model, just a minute, huh? Okay, so let's say if you have that data of 2018, 2020, and if you build model using that data, do you think that model is relevant in 2024? Of course not, because 2018, 2020 customer income can be a different, customer behavior can be different, credit scores and all those things can be calculated differently. But now in 2022, customer income is increased. Maybe you have a very accurate credit score. You have a very in digital world we can track everything. So we have much more information about customers, and that's why that 2020 model is not relevant in today's world. So that's the reason you may need to redeploy that model. I have given you very high level example. Even in today's world, we have to redeploy model every month as well, because there are some industries and there are some use cases where we need data is changing every week or every month as well. Okay, so that's the reason ML model need lot of iterations or lot of redeployment. So to do that, will you do this manually? No, of course not. You need something to do it automatically. Then what kind of automation you will use? You will use same kind of automation that we use for DevOps, CI/CD pipeline. But in CI/CD pipeline of DevOps, we redeploy application like software applications. Here we redeploy model. So that's why again few things will get changed. For model, what kind of things are required? It is a Python, which environment, how to containerize it, that will come there. Model monitoring and triggering, as I explained, it solely depend on model performance. So to understand that how model is performing, we need this monitoring and training over there. Okay, and this monitoring will give you a trigger. Okay, this model is not performing good. Maybe it is due to data drift, or maybe it is due to a concept drift. Maybe data is changed right now. You don't have sufficient data. There can be a lot of cases that will give you a hint that okay, you need a retraining. In traditional software development or in DevOps, we do monitor our software applications. We have a Prometheus and Grafana over there as well. But what we monitor there, that what is the memory consumption by this application, what is a RAM, memory, or maybe how many cores it is consuming. So basically, we monitor uses, operating system uses or hardware uses over there. Okay, but here in MLOps, we monitor our model performance along with this uh, what we call uses matrix there. Okay, so that is a high level how MLOps work and how it is different from this traditional software engineering or DevOps. Okay, then what is the life cycle of this ML project? If anybody has any question, I will take it at the last. Okay, so that it will not interrupt my flow. So next is how this model get built and how it get deployed. So first step is again that comes under model design. So in ML design, we understand business use cases, problem, and how to solve it. Then we gather some data, we collect it from client and from domain expert as well, and we do analysis of that data. So here we call it as a exploratory data analysis. Okay, so that EDA will do so that we will understand what is this data. Does this data is relevant for our use case or not? So we will look for that. Then after getting some information or insight from that data, we will do pre-processing, because data cannot be a clean state. It can be it can have some uh, punctuation mark, it can have some impurities inside that data that need a pre-processing. Then we do a feature engineering to understand what are the features which are required to us, even though there are we created new features in feature engineering. Why we create a new feature? Because see, let's say if you want to predict something, you have two features A and B. Those A and B are independently not helping to contribute or predicting something. But if you will combine those A and B, they may give you some good information about, or they may give you some good hint about predicting something. So in feature engineering, what we can do, we can combine multiple features and create a one feature. Okay, so that kind of process happens here. Then of course feature selection. If you have hundreds of feature, then you can select relevant feature or most useful or important features during feature selection. model training, where we train our model, and hyperparameter tuning means we adjust some parameter of that model. Why this hyperparameter tuning is required? Because it is, again, model is nothing but a mathematical function. It is not model means like something magical things. No, it is simply a mathematical function. So to do that mathematics, we can take some parameters. Okay, by default they take different parameters. We can adjust those default parameter to achieve the higher accuracy. Okay, so that comes under this hyperparameter tuning. Then model evaluation, same at name suggests we will evaluate our model. So till model evaluation, we have a model and it is working really good. Then what should be the next step? So let's say I have built a model and that model is in my system. So tomorrow, let's take an example. I have built model of very simple model. What can be it? Let's take the same example, customer fraud detection model we have built. Okay, so that model need customer income, customer age, marital status, all this information, and then it will say, okay, if this customer is going to be fraud or non-fraud. Okay, so how you will contact the model which is available in my system? So one thing that I can share this model with you, that will be, that will be a simple file, pkl file it will be. So I will share that pkl file with you, and you can do a prediction with that model. But that is not a effective way, because if you need a prediction, there are 100 people. Am I going to share this model with 100 people? Of course not, and that is not efficient way. So we need some mechanism that will keep model on my system only, but people from other systems or from all part of world can contact it. And to do that, we need a UI. Okay, so we build a user interface where customer will use some input and they will just click predict and they will get a prediction using this model. So that UI will connect customer or end user to this model. So this UI is built by Flask mostly here. What is a Flask? It is a uh, microwave framework. In Python, if you will do a development, there is a Django. So Django is useful to build complex applications like front end. If you want to build a complex application, you can use it there. But to build simple applications which are required for getting a prediction out of these models, we will use Flask over here. It is a microwave framework. Its name itself suggests it is a microwave framework. So it requires very less coding and it is very simple as well. So it will build a UI and now you will contact this model using that UI. Okay, that is good. But if this model is in my system, if tomorrow I will restart this system, what will happen? Uh, let's say at night I will restart this system and my system will be unavailable for next 5 hours. Then you will not able to reach the model which is available in my system. So to avoid all those things, we will deploy these models somewhere on reliable system. And nowadays we mostly use this AWS, GCP, Azure clouds. They provide 100% reliability, 100% uptime. So we deploy these models over there. So this is the entire life cycle of our machine learning model, and you may now able to relate it that how it is different from traditional software engineering. Okay. Okay. Next is, what are the issues that we are facing with without MLOps practices? Okay, so right now, let's say if you will use same non MLOps techniques, then what can be the issues? So first issue will be the low coding standard. Okay, like if you are not using this modular coding or loggings over there, then your code will become a bulky. It will be difficult to debug those code as well. So we will implement this logging and modular coding so that this code will become optimized. It will be easy to understand to other people as well. We can use object oriented programming over there as well. So these are the things that people are lagging here. Mostly modular coding and logging are the things that are lagging. Then there is a no data management system. So what is this data management system? Because see, if you are going to use a data as an input to your model, then you need something where you can store this data. Okay, So it can be a S3 bucket, it can be a local file system, but it should get managed by something. If you will use S3 bucket, so of course it will be managed by AWS. So people, we are lagging this data management system here. Like if you want to put input, you give input any data to model, then where you will store that data, how effectively you will store it, and next will be a versioning for that data. Okay, so most of us are coming from software background, so we know what is a code versioning. Like we use a Git for code versioning. GitHub is a client of Git. Bitbucket is a client of Git. Even GitLab is there. So you can do Git commit, push, all those things with this Git. So you can create a version of your code. Let's say if you are writing code today, if you will make improvement tomorrow, you will have a version. Today's code as well, tomorrow's code as well. Okay, and you can multiple people can work on same code. But what about data? How can we version this data? Because every time we are going to use a different data. If you want to train a model, if you want to do experimentation, then there will be multiple versions of data. Then that's the reason we need a versioning for data as well. But it is not that simple as core versioning. Reason, code can be of means code will not exceed more than 1 GB. I was talking about very huge code even, but if you will go and check the GitHub, you will see that codes require very less space, but data can be very huge. It can be 1 GB, 1 TB, or even bigger as well. Then will you going to update that data or upload that data in GitHub? You can update, but GitHub has some restrictions. If I remember correctly, 500 MB of restrictions is there. So you cannot upload data on GitHub having size more than 500 MB. And of course, most of the time we will have a size more than 500 MB. So that's the reason core versioning can be done with GitHub or Git, but data versioning is not possible because it has some size restrictions. Okay, and that's the reason we need something for versioning. Okay, similar for model as well. Model can be of a big size, it can be of 1 GB, 2 GB. So that's why we need a model versioning as well. It cannot be done with GitHub. Then data pipeline experimentation. In software engineering, we build applications, we do some improvement, that's it. But in machine learning engineering, we build a model and we do a continuous improvement of that model. We do a continuous experimentation of that model, and you will have hundreds of experiment. Like first time you will use model 1, second time you will use model 2, third time you will use model 1 with different parameter, fourth time you will use model 2 with different parameter. So now you have a 4 experiment: model 1, model 2, model 1 with different parameter, model 2 with different parameter. And let's say after 1 week you want to know that, okay, what was the result with model 1, what was the result with model 1 with hyperparameter, different hyperparameter. Then it becomes difficult to track. Will you track it with pen and paper? Of course not. It will be hard to track it. So that's the reason we need something to do track this experiment as well. Then currently most of the organizations are not using this CI/CD concept for this model deployment. So that is also lagging here. And in production, we need this scalability and monitoring. So I think who was it? Rajesh or someone was talking about this. Shekhar, I think he was talking about this Kubernetes. Uh, so why we need this Kubernetes? See, if you have built machine learning model, you deployed it, that model is serving for 1000 people, but tomorrow traffic is increasing and that model is receiving 2000 requests at a time. Then what will you do? That model is not capable of handling more than 1000 requests. Then you need to scale up this model so that you will have a two replica of that model. So how you can do it? You can simply deploy two different applications using Docker as well, and you can divert those requests between those two applications. But to do it manually, it becomes very difficult, and to do it means this concept or these things will be handled by Kubernetes. Uh, Kubernetes mostly provides the scalability. If you have one application, if you want to scale it up, keep its replica 3 or 4, then you just need to run one command and that application will get replicated multiple times. Okay, so that is a scalability which is provided by Kubernetes. It is mostly same as a software engineering. Then monitoring in production. So like we need some graphs, we need some visualization where we can monitor model performance, we can monitor model uses. So that can be done by Prometheus and Grafana. But right now people are heavily lagging in this monitoring portion. Even though we are using Kubernetes, but monitoring is something that MLOps industry need to integrate as soon as possible. And then cross team friction, it is same like how multiple teams can work together: data engineering, machine learning engineering, and MLOps engineering team, how they all can come together and how they can work together. That is a challenge right now. So these are the high level challenges that are there without MLOps, and how MLOps is going to solve it. Okay, so this is how this challenges will get solved. In code standard, we can integrate this modular coding. We can add this logging for debugging. Even though we can add these artifacts, components, and pipeline over there to manage it, so that can solve us, or that can create this pipeline more efficient. In code versioning, we can use this Git and GitHub over there. Then for data and model versioning, we can use this DVC and ML flow. So in this course, we are going to cover this DVC and ML flow over there. Like DVC will helpful for data versioning. It name itself is data version control. So DVC will helpful to versionize our data, and ML flow will helpful to track those experimentation phase. Okay. So we are going to work heavily on this ML flow and DVC in this course. Next will be CI/CD tools, where we will learn how this GitHub action work, how we can write CI/CD.YAML pipelines, and how it will automatically create an image out of our code. Okay, so these are the things that we are going to use here. Next will be containerization, that we will do with Docker, and we can push those images to Docker Hub. Okay, so I will cover Docker in this course as well. Then next will be scalability and monitoring. We will cover this Kubernetes. Again, this is very vast field, but we will cover basic of Kubernetes, like so that you will understand how can deploy and what are the high level things in Kubernetes. And Prometheus and Grafana, of course, are there to do a model monitoring. If time permits, then we will go with AWS services as well, like this IAM user or ECR instance, S3 bucket, EC2. Why we will use it? We will deploy this ML model on AWS as well, like ML flow pipeline on AWS, or simply deploy ML model using Docker on AWS. So that's why we will use these services over there. Okay, so if we will use these things, it will solve most of the problems that MLOps industry is currently facing. Okay, yes, there are a lot of tools in this industry. See, this is a list of those tools that they are available over there. Okay, so there are a lot of tools available. Is it possible to you to learn all these tools? Of course not, right? Because it takes a lot of times and it takes a lot of expertise as well. So to avoid this complexity, what we can use open source tools that can be used across industry, across domains as well. So these are the tools that I have mentioned here, that Git, GitHub, DVC, MLflow, GitHub Actions, Kubernetes, Docker, Prometheus, and AWS services. So these are the optimized way to optimize our MLOps pipeline. Okay, and these are the optimized tools that we can use. Okay, so that was it from my end. If anybody has any question, then we can take it here.
Yeah. Hello, Pramod.
Hi, Sobers.
Yeah. So one question I had about is this machine learning ops. So how do we define in two lines? Like, is it machine learning ops is a practice, best practices, or it is about tooling? Like, we need to master the tooling, because I got one call from one of the job consultant, and basically from DevOps, but she told that you should have ML ops as a in your skill set. So is it a practice like DevOps is a practice, same way, and ML ops is also practice, or it is about the tooling part? We need to master some tool. So you can explain in two lines, that will be really appreciated.
Definitely. Yes, DevOps is a practice, MLOps is a practice over there, but how we will follow that practice, we need some tooling, of course, there. So it is about learning tools as well. And the tools which I mentioned in front of you, they are mostly used for it. Most of them are overlapping with DevOps, but there are tools that are specifically used for machine learning as well. So I will not say it's just a practice, but it is about tooling as well.
Okay, and secondly, in the current slide, point number 3, data model versioning, maintaining data pipeline experimentation. What you have written: DVC, MLflow, Neptune, Seldon, Qflow, ZML. These are the these are the MLOps tool, or like I'm not understanding. These are the ML
Yes.
ops tools here in the slide, which we'll be
Yes.
covering in this session or this course of MLOps. That
Yes,
is
you are
not
right.
clear.
Yes, this okay, let me go there one more time. Yeah, see, here we are going to cover DVC and ML flow. Okay. In data versioning, we will cover DVC. In model monitoring, sorry, model experimentation, we will use ML flow over there. And in bracket, we have this Neptune, Seldon, Kubeflow, and JDML. These are also tools which people use, but they are not going. We are not going to cover it in this course because it will then course will become too much lengthy. So we will use most widely used tools. These are DVC and ML.
So DVC and ML flow. These are the tools
Yes,
that we'll be focusing on for this course,
yes,
right? And that will be related with ML ops only. Okay.
yes,
So
yes,
it can be used in any platform like Windows, Linux, across
yes,
any
it can
platform.
be. Yes, yes.
Okay. Okay, got it. And secondly, for this ML ops, before joining the course, we do there is any prerequisite, right? We should have a basic foundation or understanding of DevOps tools or a basic SDLC cycle or something, that will
Hmm.
really be as a what do you call as a mandatory thing before joining the
Got
course.
it.
Anything?
Yeah, actually, we already discussed at the start of course. Maybe
Yeah,
you have
I
joined
sorry I
late.
missed that thing. I joined late because of I have to pick
No
up my
problem.
son from the school. Yeah, yeah.
No problem. No
So
problem.
can
See, yeah,
yeah.
so if anybody else has joined late, so prerequisite for this course is very simple that you should be aware about Python, or if you are not aware about Python, as I already covered Python in my last batches, I will cover Python in this batch as well, so that you will get a basic of Python. Definitely, it's not a advanced or expert level Python, but you will understand what is a Python, how it works. Okay, so that is the one prerequisite. Second will be you should have a basic knowledge of machine learning. Okay, that how machine learning works, what should be the input, what can be the output, and what are the types of model that we use. So understanding machine learning, I mean, like, you should not be expert of machine learning, but at least you should know that what are the terms that we use in machine learning, because when you will deploy model, when you will monitor model, those terms will come in picture. Okay, so that's why machine learning understanding is needed over there. So that these are the two basic prerequisite. And for about tooling, I means I have a belief like that learning tools is not difficult task, so we can learn it, and there is no prerequisite for tooling. But if somebody is having knowledge of these tools, Docker, Kubernetes already, then that will be the beneficial for them.
Okay, so what I understand from your from the conversation that we should have a basic understanding of Python scripting and machine learning language, right?
Yes,
These are
yes.
the
Even though
these are
even though I'm going to cover Python, and I'm also going to cover machine learning. Like if
uh,
somebody is coming from non-IT background, I am
uh,
sure that if I will take a 1 or 2 session, he will also understand what is this machine learning, how it works.
okay,
So
okay. So you'll
I'm
be
going to
covering.
cover basic of both. Yes,
Okay,
even though
so
there is a prerequisite, but I'm going to cover it.
okay, so basics you will be covering of Python scripting and machine learning language.
Yes,
Okay,
yes. Just
fine, fine.
to say one before taking a next question, let me say you whatever committed timeline, like whatever there will be a official committed timeline, we are definitely going to exceed it. Okay, so just keeping your expectation clear that if this course is for 45 hours, I think it is 45 hours, 45 50 hours course, but it will take almost 60 to 65 hours to cover everything. Okay, so yeah, we are going to exceed our timeline because we want to cover most of the things those are require for this course as a prerequisite, but we are going to cover here. That's why we will exceed our timeline. So just keeping informing you all that we will. Okay. Next is please.
Okay, so 50 to 60 hours means it will take how many? Like every it will be it's a weekly course, right? Set a weekend course, right?
That I
Or
need to check. Currently, I have batches. They are daily batches, and weekly we have a off. Daily 1 hour I took a session uh,
uh,
from Monday to Friday,
okay,
and Saturday Sunday they do a practice. But these are the things that I think management will decide that how they want to take, and maybe it's depend on all of your availability as well. That if you want to go with weekend batch, daily batch, it's up to you.
okay. Thanks a lot. Okay.
Okay, thanks so much.
Okay,
Yeah.
Pramod. Uh,
Yes.
I have
Yes.
two queries. I don't take more time from your end. So, as like DevOps, we mostly focus on continuous integration and continuous deployment. So, in this MLOps, are we focusing on continuous integration, continuous model training, and continuous deployment, right? So, in continuous model training, so what tools we are using, like how we are modeling that and how we are monitoring it. And the second question, once this batch gets completed, so are we doing any kind of end-to-end project? So I
Yes,
have this.
right. Yeah, yeah. Thanks for asking that question. By the way, yeah. Whenever I explain anything, I explain that taking a project only. So I don't explain it in parts. I take one project, I build it using these multiple concepts. So definitely there will be a multiple end-to-end project, not only one. Second will be I always prefer to write code in front of you. I don't do coding in the background, and then I will come in front of you and share that code. Okay, this is the code how it works, and then it will how we will deploy it. Even though I write a script in front of you for CI/CD scripts as well. So uh, it is it regarding tools. We will use same tools that we use for DevOps, because for CI/CD again it is a concept, and to fulfill that concept in market we have tools that we already use for DevOps. Same tools we will use for MLOps as well, like GitHub Action we can use here.
I mean, like for model training, what tools we are using?
For model training we need a language that will be a Python language. We don't need a tools for that. You need a IDE that can be VS Code, that can be Jupyter Notebook, that we will use. Yeah, for
Okay,
training we don't need any tool.
okay. Thank you, Pramod. Thanks for
Yeah,
that.
thanks Elias.
Yeah, Pramod. So I have a few questions here. So my first question is, how can we decide the compute in the Kubernetes? For example, is our data is increasing, correct? So do we need any calculations or anything? Do we maintain to calculate how much CPU and how much memory is required?
Okay, sorry, I was speaking on mute. Then, yeah, to answer this question, nowadays it becomes very easy, right? We can just even AWS provide integrated monitoring. Like if you purchase any instance, there is an integrated monitoring about this CPU uses and memory as well. And if you don't want to use it, then you can use this Prometheus and Grafana. Integration of Prometheus and Grafana will give you a high level, not even high level, it will give you a very deep detail about your model, sorry, matrix uses. If means I think maybe I am not clear about your question. Can you explain it one more time? Is it like how to monitor, or is it
No,
something different?
no. I'm just asking about what is the compute CPUs and uh, how many cores or CPUs required, how we can decide. So as the data is increasing, right? So do we randomly select the CPUs in the Kubernetes cluster, or do we have any specific calculation how to find out?
uh, Space, to be very honest, uh, so far we have used a random CPU cores over there, but I'm sure as you are asking question, I'm getting some what we call backflash in my mind. There are some methods, either it is to calculate, or I think there are some expert who decide it. I will not answer this question. Maybe give me some time. I will just go through it and then give you a correct answer rather than giving you false information.
Yeah,
Okay,
yeah.
okay.
Yeah, Shekhar, just to add on this, because I have also worked on Kubernetes. So this challenge we also had whether we should be using the random CPU and memory usage. So what we did with the help of Datadog, we calculated. Say there are 50 services running. So on average, what is the CPU and memory utilization taken for each service? And we created three categories. One is high, medium, and low. On basis of that, then we put the CPU and memory usage in that Excel sheet and the services, and then accordingly we configured. Okay, this is the one of the way or techniques, I mean, we are using in our live projects, and maybe sure it will be helpful for you. So basically we are uh, taking the average of any service, how is the memory and cpu utilized, and then creating an Excel sheet and putting in that, like high, medium, and low, and then categorizing accordingly, and then assigning to a service. Okay, this is we are following for our live project. Yeah, I believe it may help you to answer the question what you have asked. Okay. Yeah.
Yeah, I got it. Yeah, thanks.
Okay.
So, so just to understand it more, like let's say if you have one service, you will consider a average of that uses. Let's say how much memory or how much RAM and it is consumed by that application. You will put, let's say it is consuming 10 GB, 10 GB both. Okay, so average of course it is a 10 GB. Then you will put one more average of higher uses, maximum side uses. Let's say it is 20 GB. Okay, then you will say, okay, when your application is running on 10 GB RAM and 10 GB memory, then you will keep three cores. If it will exceed 10 GB, then you will keep four cores. Is it like that?
Yeah, exactly. Somewhat you are on the similar line. So what we did, the DevOps team, we had a meeting, and even there were some consultants also there, which we have hired. So this was one of the challenge. Like we should assign the memory and CPU dynamically, which will be given by the Kubernetes at runtime, or it will be manually. So what we did is that as per our deployment, last 2 3 deployments, we took the average and we created three columns. One is the high, medium, and low. Okay, and again in high, medium, and low, we created the memory usage and CPU, and accordingly then basis on that, say service A is consuming something like uh, 10 cores, core CPU. So then somewhere we assign is 10, and memory is something like whatever 200 or whatever the figure you can think of. So then we calculated as is it a high, medium, or low. So we have again set a range. Like if it is less than 50%, then it is low. If it is more than it is between 51 to 75%, then it is what do you call medium, and 70% and above, then it is high. And on basis of that, we have calculated one table, and then we have put note down all the services basis on the Datadog metrics, and then we have put it. I mean,
Oh,
sometimes we have to do little plus minus here and there, but this is how we are using currently, and it is working fine.
okay,
I hope I
okay.
have answered your question, or you need a more clarification on that.
No, no, no. It is clear source now. Yeah.
Yeah,
Thanks
no,
for
yeah, I mean,
discussing real world
yeah,
problem.
yeah. So basically, the whole idea is that we categorize into three this parts. One is the high, medium, and low, and then we have to decide that your given service XYZ is in which category. It is high CPU memory usage, medium, or low. And as per that, then we have to put that service in that Excel sheet. And who a DevOps engineer, when they configure the YAML pipeline, I mean the this manifest file, then they will go to that Excel sheet and see what is the parameter we have assigned for that particular service, with the high, medium, and low, and then accordingly they will enter in the this manifest file. Okay, this is how we are doing currently for our project.
Got it. Got it. Yeah. Thanks for elaborating sobers.
Yeah, no
Yeah.
problem.
Pramod, I have a question actually. How this course helped me to get into MLOps roles? Because consider my profile, I have 8 years of experience, that too into mostly into administrator roles actually, where I had to
Mhm.
use, I never use scripting also. So even I don't have a basic knowledge of MLOps.
Okay. Got it. Yeah.
Yeah.
See, first thing, like if you want to do a career transition, we need a confidence. that okay, even though I always say that you don't need 100% knowledge of anything, but you need 100% confidence that how things work. So if you will go through this course, you will build some pipelines, you will do some deployment, you will understand what is the end-to-end flow for this MLOps, and you will understand, not only understand, you will gain a confidence. Okay, first is that thing. Second is you can add these tools in your resume. It will help to filter your resume out of other candidates, and even you can speak on these tools during interview as well. So very shortly, these are the two things: you will gain a confidence and you will have a knowledge about these tools that are used there.
Okay. So you will be sharing the projects as well, right? To put it in the resume.
As I mentioned, I will build projects in front of you, and will
Okay.
update in GitHub. Even you can clone and you can run them in your system. You can put them in your resume as well.
Thank you.
Mhm. Yeah.
Pramod, I have another question. So, as you said, for UI building and everything, you'll be using Flask, correct? So,
Mhm.
Flask. So, on top of the Flask, do you use Streamlit or HTML to design the page,
We
where
can
the user?
Yeah, we can use Streamline as well. But as I mentioned, there are a lot of tools to do particular things. If you can do a build a sorry, we can build a UI using Streamline or using Flask as well. It's up to you that which one you want to select. Okay. So I have selected it Flask. If you guys want to select Streamline, then I will integrate here in this course. But we can only integrate one out of it. Otherwise, this course will become too much lengthy, and I know you all are experienced people. You don't need want to learn these tools and all. You just want to know what is the end flow for this MLOps, right? So I will not means it's better to focus on one tool rather than diverting to multiple tools. But yes, answering your questions, yeah,
Yeah,
Streamlight
yeah,
is used.
yeah.
It has a similar concept.
Okay. And the other question is, where do we store the data? For example, if it is small, as per my understanding, we just store in S3 or in GCP, some GCS bucket. But do we store in the vector databases also? I mean, if the data is too huge, if it is terabytes or something like that, for the training data sets.
Sorry, can you repeat your question? Initial portion. I was having some lagging.
Yeah, so for machine learning and everything, the training data sets, where do we store the data in real time?
Okay, okay, got it. Yeah, it's again depend on use case that which kind of data you have. If you have a textual data, if you are using LLM models, then of course you will need a vector database for it. But if you have tabular data, even you can store it in S3 buckets on the services which are provided by AWS or other cloud platforms. There are some big data platforms as well, where you can store your data. These HDFS file systems are there. Okay, so yeah.
Okay.
Yeah. Sorry, Rajesh, can you? Your voice is very low. Rajesh, we cannot hear you.
అంటాడా మన హ్యాపీ ఎక్కుతున్నాం అనుకో
Can I ask the question?
Yes, Akshay. We will have 3 minutes. We can take this question.
Okay. Just one simple
ఇప్పుడు
question. My
పాప
question is related to the
నా
step one. We
దగ్గరే
do
ఉంటాడు రా
installations,
వాడికి
right?
ఎవరికి 20,000 ఇచ్చాను కళాశాలకి
Just a minute.
So
Rajesh, can
నేను
you
పని
just?
చూడలేదురా సార్లు ఎత్తుకుని తిరుగుతుంటాడు రా కళ్ళ ముందు మాట్లాడతారా మాట్లాడు అదే లాస్ట్
Hello, ma'am. Are you there
మాట్లాడగలిగా
from Visualpath? Can you? Yeah. Okay. Thanks.
all right. So
Okay.
my question is related to the installation part. Are we going to install all the dependencies and libraries on system wide, or are we going to use the virtual environments?
We are
Like we
going.
use requirements.txt file to install everything, right?
Yes, we need to follow that approach only. Otherwise, it will become very difficult that if that code will
Uh-huh.
that will run in my system, and if I will share with you, you will find difficulties to run that pipeline. So that is the best approach:
Right.
create a virtual environment during a
Okay.
development. But during
Uh-huh.
deployment, rather than creating virtual environment, we only use a Docker there, so we don't need virtual environment.
Okay.
So
So
before,
yes, I have many questions related to that process, but maybe I'll ask them. I'll ask later. That's it. Thank you.
okay, got it. Yeah. So these are two things: creating a virtual environment and creating a Docker image. They both are same. Purpose of both is like creating an isolated environment. So during development phase, we use virtual environment, and during deployment phase, we use a containerization method.
One more follow question to it. So once we activate the virtual environment and we enter it, we install everything in the environment we are using, and then we deactivate it. So can we go back to the same environment again, or do we have to do it in just one go?
No, 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 no. If you will create a virtual environment, you can activate and deactivate it
Mhm.
multiple times. It doesn't matter.
So we can enter it again, right?
Yeah, we can enter it again. You don't need to re-execute all
Okay.
these dependencies there. They will be already there.
Okay. All right. Thank you.
Mhm. Yeah, thanks, Akshay. One last question.
Yeah, Pramod. So basically, I'm just trying to understand. ML Flow is basically like it's a separate tool, correct? I mean, we need to install in some VM instance in order
Uh,
to do the search.
Yes,
Yes.
there are two things. You can install it on VM systems. You can install it on local system as well. Even though you don't need to install, there are some. It is a GitHub Actions, not sorry GitHub Action. It is a DAX hub. On DAX hub, you can directly integrate this ML flow as well. So yes, it is a tool you can install locally or remotely, or maybe on some Git clients as well.
Okay. And how is this ML Flow and Docker doing the relations?
ML flow is for experiment tracking. So when you will run pipeline, ML flow will be there. So result of ML flow is machine learning model. I will say it will just run your entire pipeline, and at the end of the pipeline, you will have a machine learning model. Then from there, Docker will pick that model, it will containerize it, and then it will take care about its deployment. So they both are not related. They comes one after another. First ML flow, run all pipeline, and then Docker pick that model and deploy it somewhere.
Okay. Okay. Got it. Yeah. Thank you.
Hi, I have got a question. So right
Yes.
now, if you search for like MLOps engineer, right, those jobs are not like much, are still it's in very early stages, right? So in your opinion, do you think like 10 years before, like 2015 around, if you search for DevOps engineer jobs, the term just then was coined and there was no jobs outside. But 2, 3 years later, it was popping everywhere, right? So, do you think MLOps is still in that stage where DevOps was adopted like 10 years before? What's your opinion on that?
I will agree with you. It is in still in the same space, but space is very different right now. Multiple companies, not multiple, every company is opting this machine learning. So they will have a multiple models maybe after 2 or 3 years. And once you will have a multiple model, then it will become difficult to do deploy them or retrain them or redeploy them. So in coming years, there will be a huge requirement for MLOps, and I will say whenever things goes beyond a limit, multiple MLOps engineer means even ML engineer will do work of MLOps engineer. So that will be there. Yeah, but you are absolutely right. It is evolving field. It is very new right now. Most of the people, there is no tools or tags which are popular in this industry so far, and there are lagging of this best practice as well.
Correct. So, right now, the expectation has come for like developers should also do the DevOps work. Still, like DevOps is prevailing. It will prevail for like few years down
Exactly.
the line, I believe. So, with this ML apps, do you think like whoever is developing the mission model, it is as easy to manage the ML ops also, or do you think like right now because DevOps is like they're taking care of like networking, DNS, and multi hybrid cloud with data centers, everything, right? Everything came under DevOps umbrella from the traditional data center, right?
Yeah.
So this ML ops would be like something similar that would be easier for data scientist people who
Yeah.
can take care of all these things, or it will evolve as like a own stream on its own.
It will definitely evolve as a one stream, because see, data science itself has a very different background than this software engineering. Because what is MLOps? It is a software engineering at the end, right? So data science or ML or data engineer is completely different field than this. And one people or team of people cannot focus on both things. Means you should be expert of mathematics and you should be expert of software deployment as well. That is not going to be possible. One people will not have a both skill. So it will remain isolated. There will be a expert in the industry who will completely manage this deployment portion or
But
operation
very
portion of.
few.
Yes, very few. And a large quantity of people will develop these models, and they will also help these MLOps people for small deployments. But of course, there will be any challenges if you want to scale this model, if you want to handle this complexity regarding networking and all, then MLOps, expert MLOps people will be needed.
Just one more clarification. So even with DevOps, right? Like I work with like different different development team every day, right? So similar to that, MLOps will also work and interface with different model development teams. It would be kind of similar to that, or
Yes, uh, I will say it will be kind of similar, but it is not kind of similar right now, because as we mentioned that it is new field. Uh, for each company, for every domain, there is a different practice. Yeah, so I have seen companies where ML engineers are also heavily involved in this ML of things, and I have seen companies where this ML and ML of engineers are, these are very separate departments. MLOps engineers are considered as a system reliability teams, system reliability
oh,
engineers. We consider that there. So again, it is depend, but currently it's very hard to forget them. Currently, it is hard to say they are integrated, because it's evolving. Maybe after 2 or 3 years, they will get. It will be similar like a DevOps.
okay, yeah. Thanks for your time. Yeah.
Yeah. Okay, then I think we are already exceeded our timeline, and I have a next meeting as well. So if anybody has no question, then we can close this session. But if you still have any question, you guys can just write them down and we can discuss them in next session.